Now this one add more hydroxide, so beyond becomes point, which means if it's beyond, you may have this much of hydroxide and weak acid, but you have extra, hydroxide. So if you use this much cancel, you still remaining hydroxide ion. So that will be just strong base. Strong base. Next. Yeah.
17.
17. The concept of ammonium, hydroxide, pH. Wow, you have to take a lot of stuff. This one, and pH. Also mentioned that initially that. So initially that concentration of ammonia and that concentration of hydroxide initially. Kb is that. Okay. This is similar problem we did in the weak acid case. So they don't react because they are not in the same side. They do not react. So you set up ice table. This guy will dissociate X amount by X amount. They will add X amount to ammonium. They will add X amount of hydroxide. So at equilibrium, product over reactant. And that's equilibrium constant. But when I look at the reactant, that's a base. So it's a Kb. And the Kb value is given right here, 1.8 centimeters. On this side, again, you approximate that as you can ignore X. Then you solve for X using this. And that X is our ammonium ion. So once you solve for X, X is our ammonium ion. That's what they are asking, one of them. But you also have to find out hydroxide concentration. So which means once you find out X plus 0.057, that is your hydroxide. And then once you know X, you will have, okay, pH. Because if you know OH, then you know pOH, and then you know pH. Okay. Next.
Find the ammonium ion. Would we just take X minus 0.057?
Our initial condition was for ammonia, that was this number, and then hydroxide was that number. So at equilibrium, if a certain amount dissociate, it will add to X to both of them.
Right.
So this will be X, not X minus 0.057.
Oh, I see. Right. We get rid of the 0.057 when we're doing that. Okay. Thank you.
15? 15. It's almost 7:30, but I'm gonna be here until 8. I'm gonna continue. As long as you are here, I'm gonna continue until 8 o'clock. Okay? 15. Equal volume of this are mixed. That's strong acid. This is strong base. So you do not have a buffer, you do not have a salt. It's just neutralization.
Is NaCl
And then one more, same concentration and also same volume. So nothing, it's just become water. So what is the pH of the solution prepared by using solution? 7.
That's not a strong base. That's a salt.
Matter said that. Who said that? You're right.
Thanks.
Yes. Oh. Yeah. Okay. Okay. I thought it was NaOH. Okay, that's salt, and there's just strong electrolyte. Okay, that's not NaOH. What did I say? Okay. So so strong electrolyte, complete dissociate does nothing. So basically, we have only this guy. But the thing is, although this guy does nothing, still we are adding equal volume. So still you're gonna dilute as half of concentration. Okay, so we have half concentration of H plus. So that will give us pH. So this guy, negative below this concentration, that will be our pH. All right. So be careful when you use the question. Do not use this as NaOH. Okay, I made a mistake. What is next?
How do you know? I'm still confused on like when you half the concentration. How do you know when you need to do that?
So you are mixing this guy with equal volume, right? So I don't know what the volume is, but whatever you have, you're gonna have to add equal volume of something else. Although this guy doesn't contribute anything at all other than adding volume, but if you double volume, concentration should become half.
Okay.
Okay. So I just read the question and then see what I have. That's how I just calculate concentration.
Okay.
Go ahead.
If it was a weak electrolyte, how would that change the problem?
Weak electrolyte NaCl, not NaCl, NaCN. No, that's not weak electrolyte. That is still considered kind of pretty much dissociate. Which one would be weak electrolyte? Are you asking this case or something else?
Well,
Weak electrolyte, right?
sure.
So not this one?
She was asking Ines with that question, what would happen if that was a weak electrolyte?
Yeah, I
So
understand.
strong.
Yeah.
Like, what if you had to do something with that
Yeah.
other ball? Like,
Weak electrolyte, which one? Let me see. Now, weak acid will be weak electrolyte. Let's say HCl. This is one of the weak electrolyte because it just dissociates only partly. So weak electrolyte could be weak acid or weak base. So we can classify different problem, right? Weak electrolyte could be weak acid, weak base, or other salt that doesn't dissolve much. Something like barium sulfate. This is just salt. So we have 3 different kinds of weak electrolyte. So let's consider one by one. If this is the case, we have weak acid plus strong acid. So you ignore this pretty much ignore it. It will be pretty much this, but still this will dilute. So this case will be almost like this problem, current problem, okay? Even though we electrolyte, because that doesn't do much. What if your weak electrolyte is weak base? Now this guy will neutralize some of that. So depending on if this guy is less amount, then this guy will titrate part of that. So you're gonna have less amount of still strong acid. So number will change, but it will be still strong acid. But what if this guy is more than this guy? Then we have a buffer. So we have very different kind of scenario of weak electrolyte. Third one, this is also weak electrolyte. If you have that guy, some of them dissociate, some of them stay as solid. Okay? So then, now we're gonna have different type of problem, if this is the case, this guy will, so this is supposed to be an acid-based problem. We finish this guy, now this one become like a solubility problem. Because this will dissociate like that. And then if you add acid will react with that guy. So that guy turn into bisulfate. So that will be a completely different problem. Okay? So in the end, depending on which one you have more, let's say this is less than that amount, then whatever happens here, you're gonna still have significant amount of weak strong acid available. This will dictate pH.
So you only use the concentration of the.
Pretty much.
Okay.
But if you have more of this, then that acid will be all used up to convert that guy to this, which means now you have conjugate base. So it will be istable starting from this guy, because all of that turn into this. So your question was very good, because we just reviewed all the different aspects of weak electrolyte. Okay? All right, what's next?
How do you start 30?
30. Okay. This is I see the constant of this guy is half of this. So at equals point, I'm gonna need half of this. Right? Constant is double, that means you need half amount to reach equals point. So in that sense, for B, we reach at equilibrium point. So H actually will, wait. Yeah, right. This guy, because they are both strong base, strong acid. At here, we have just water, so pH 7. So before that point, we have more. So we are adding acid to base. So this will be basic, right? So this is basic solution. And then here you're gonna add more of acid than base. It will be acidic solution. So basically you're gonna find the concentration of this guy, and then calculate either pOH or pH. Okay?
Can we do those?
Hmm?
Can we do those?
Let's do that. For A, so we need to find the constant hydroxide. Well, here, hydroxide, we have 25 times 0.16. What is 25 times 0.16? 25 times 0.16, 4. I have 4 millimole. And H plus is 12.40. 12.4 times 0.32. 0.32 times 12.4, 3.968 millimole. So when they react, small amount will be all used up, and you're gonna have that many more of water. We are not interested in the water. This guy will be equal to 390.032 millimole. So we have this much hydroxide, So our concentration is 0.032 millimole divided by total volume. Total volume is 25, you add 12.40, 37.40 milliliter. So concentration is what? 0.032 divided by 37.4. So 0.0008556 to 6 feet. So pH, we can take pH. Okay. Negative low or common. B is pH 7. Now C, for C we have an extra hydrogen ion. We have a hydroxide as still 4 millimole. This is for C. And hydrogen ion is 12.6 times 0.30 0.32. We have 4.032 volume. So we have extra hydrogen ion, which means this guy is 0.032 millimole. Inside of total volume is 25 plus 12, 37.60 milliliter. 0.032 divided by 37.6. 0.000851. So you can calculate pH. Next.
I have a question from the
Yeah.
practice exam. I have a question from the practice exam,
Okay.
whenever you're ready to move on.
Okay. Yeah. Any further new problem? If not, we're gonna move on to our practice exam.
Yeah, that's fine.
Right. Give me the number. Which one?
Number 11.
11? Okay, 11. Yeah, selective, that's a good choice. Yeah, that is a negative. Right. Alright. So this guy is barium plus sulfate. This guy is strontium. Wait a minute, is the same? Okay. 2 plus SO4 minus. Yes. Alright. And then you are adding sulfate to solution of barium and this. Okay. So this number is 1.1 10 to minus 10. And then our concentration of barium is 0.01 here. This is strontium is what? It's the same. Okay, it's the same. Bring orange and sulfate. So for this guy, if you divide by this number over here, this sulfate is supposed to be, if you divide 0.01, 2.8, 10 to the minus 6. Divided by that, sulfate concentration will be 1.1, 10 to the minus 8 molar. Because this is smaller number, if it's a smaller number, you need less amount here. So this is not prepared first. So this is necessary ion. Okay.
How do you know, so you took your concentration of 0.01 molar. Why didn't you have to subtract from X for that? Or did you and that was just skipped? Oh, never mind, because it says it gives you the concentration of the ion alone. Never mind, I answered my own question.
Yeah, because
You're
that
good.
was already just there.
Okay.
So which to keep on prepare first? Yeah, that one first. Which means barium first. Next.
Can you do B and C of that question too?
Oh, is it C?
Yeah, I
Oh.
can't get C right.
Oh. Oh, alright. So when sulfate ion, this. When sulfate ion is this, that's when barium will start precipitate. But when your sulfate ion reach to that concentration, that's when this guy also strengthens.
I can't figure out how to do C. Or is that what you just said? I saw that for a second.
Yeah. So this is KSP for strontium ion. So KSP for this guy is strontium times sulfate. And then they already told us strontium ion concentration is 0.01. So if I use this number is this here. So I can find the sulfate concentration should be at least this to make up precipitation.
Right.
That's what they ask.
So it needs to
But-
reach that concentration for the other one to start. So the answer is just
No,
the one.
a lot of the sulfate ions are used at making the precipitation for the first.
I see your point.
And then
I see your point. Okay, alright. Yeah, okay. Yeah.
and then so much more are gonna have to be added before the.
But they are not asking, although that's a valid point, they are not asking how many more you should add. They're asking what should be your concentration. So let's say this. You have two ions in the solution. Then when you start pouring a sulfate, the sulfate will be used up to make a precipitate of first guy, right? And it will be gone.
Right.
So now you have to more to precipitate the second ion, just because you already some of them used for first one, right?
Right.
But still, they are not asking how much of sulfate solution you have to add. Then you're gonna have to consider both of them, right?
Right.
They are not asking that. They're asking what will be concentration in the solution. What molar concentration of sulfate ion is necessary? So this constant is in solution. So when you add, let's say I added this much, and that was used to remove all of this guy.
Right.
Okay. Now I'm going to have to add more to start precipitate this guy, right? So if you use this already certain amount, obviously that will impact overall amount you have to put. So in that sense, it will affect how much you have to add. But that's not they are asking. They are asking what will be constant molar sulfate. So when you add this guy over here, concentration SO4 in the water will increase, right? If you add more, concentration increase. So until this concentration reach certain point, none of them will precipitate. But if this one reach certain amount, that's when this guy start precipitate this guy, right? And then you just keep adding it, and then this guy precipitate. At certain point, all of them will be gone. And that's when, right that point, concentration of sulfate will be 0 here, right? Because that's all just used to remove that guy. So again, you keep adding it, concentration increase from 0 to, it will rise to up to the required amount by this guy.
Okay.
So that's what they're asking.
Sounds good.
If the question was, how many milliliter of sulfate do you have to add, or how many more of sulfate do you have to add, you're gonna add this to that amount.
Okay.
So I think that was your thinking, and that's very reasonable idea.
Can you do 2?
2. Which of the following solid is more soluble in the acidic water than water? Okay. So when you have acidic solution and just water, which guy can dissolve more here, right? If something made of from strong stuff, barium is not strong stuff. If they dissociate, if any of them react with acid, then this acid will help remove those products, the solubility will increase. Okay? So question is any of product will react to the acid or not? This guy do not react. So there's not much difference here, whether it's pure water or having acid, because they do not react. So you look at the